Okay, everybody. I'm very excited today to share this collaborative research, which is called a free span system with moment limited connection. So 2 weeks ago, here has an earthquake happening in China. There has a very beautiful building before the earthquake, but after the earthquake, the weak story collapse, it happened. It's very common failure mechanism for frames. So how to prevent the weak story collapse? Because this limits the energy dissipation of the building. So some professors propose to a elastic span into the building to impose more uniform drift profile over the head of a building. So this is typically composed of a lateral force resisting system and a stiff elastic element that will make the plastic hinge is more uniformly distributed along the head. But because of the span is remaining elastic, so the hair mode response will be bigger. So some professors propose to use a force limited connection called FLC to reduce flow acceleration, such as the friction device. And the FLC typically is between the frame and the span. Recently, a US-Japan project to conduct a shapeable test on the A-defense. And in here, we use a span to mitigate the story mechanism. And we also use a FLC to control the force between the frame and the span to reducing the flow accelerators. So in the first floor, we use a T-shaped damper, and in the third floor, we use a U-shaped damper. Okay, so in summary, typically for frame span system, we usually compose of three components. The first one is the frame, right? And the second one is we use a elastic span, and between the frame and span we usually use some connection to connect each other. So if we want to limit the hair mode response, we could use the force limited connection, because under the earthquake there has significant shear force between the frame and the span. So if we use the shear damper by the U-link, we can limit the force. So, but in this research proposal, I have tried to another alternative solution. I use the rotatory damper to control the moment between the frame and span, not the shear force, because under the earthquake, not only have the shear force, but also have a significant moment between the frame and the span. So this is called a free span system with moment limited connection. But the question is, what is the moment limited connection, right? So I propose a rotatory friction damper. This damper is composed, in the center, we have the hinge pin to provide the force resisting capacity, also to produce a rotatory behavior. And around the pin, we take a lot of the preload bolt to prevent the moment limited connection. Because this preload bolt, it will have a friction force. So if we multiply the friction force and the distance between the bolt and the hinge, it is the moment limiting capacity, right? So I have take a Cosi test to justify the rotatory damper, and we can see here is a very stable sliding rotatory behavior between the moment, right? And the results is also very perfect. So the next step, I have to do a numerical model. The first one is just a free span with the pin connection. The second one is a span frame system with moment limited connection. Okay, and we can see, because we use the moment limited connection, so the drift is reduced from 2.38 to the 1.85. And not only the drift, but also the acceleration is also reduced from 1.61 to 1.22. So here is my proposal, a free span system with moment limited connection. Thank you.
Thank you, Dingbin.